Welcome to my channel. My name's Dan, I'm the Reverend, and in today's video I'm going to be serving some spicy facts about the planet Neptune. So far we've only flown one spacecraft past Neptune, and this was in the summer of 1989 as part of the Voyager missions. Voyager 2 passed 3,000 miles above Neptune's North Pole, which was its closest approach to any planet since its launch from Earth, which was a staggering 12 years beforehand. NASA was able to capture some spectacular images of Neptune and one of its nearby moons Triton from this approach. It took 4 hours and 6 minutes for information to be relayed between the Voyager 2 craft and Earth from this point. This is due to limitations of the universe, as you can only send information as fast as the speed of light, and it was really far away. Using this time, and knowing the speed of light, which is at least above 4 miles an hour, we can estimate that Neptune is 2.7 billion miles away from here. Voyager 2 led us to discover that Neptune has a ring system like many other planets in our outer solar system. These rings are very faint, they're certainly not anything like Saturn's rings, and they're speculated to consist of ice and dust. It takes 164.8 Earth years for Neptune to make one full rotation around the Sun. The 11th of July 2011 marks its first full rotation around the Sun since its visual confirmation of discovery by a German astronomer in 1846. This astronomer was called Johann Gottfried Galle. I say visual confirmation of discovery because Neptune's existence was actually predicted mathematically before it was observed by a French astronomer whose name was Urbain Le Verrier. Please excuse my pronunciation. A discrepancy was noticed in data from the orbit of Uranus. The predicted position and the actual position did not match, which led astronomers into believing that there must be a strong gravitational force pulling on Uranus. The source of this gravitational pull was found within 1 degree of its predicted location and is now the 8th planet from the Sun, Neptune. Although Neptune is 3.9 times bigger than Earth, it's much less dense. This is due to it being made of hydrogen, helium, methane and water in its upper and middle layers. This means that it isn't actually possible to land, let alone stand on the surface of Neptune, because by the time you've reached a solid surface, the rock and ice core, the atmospheric pressure would be so intense that whatever vessel you were travelling in would become crushed under 10 gigapascals of pressure. This is 100,000 times more than Earth. Both planets have an inclined axis, meaning that the northern and southern hemispheres can be closer to or further away from the Sun, depending on which position the planet is in with regards to its solar orbit. One thing you do need to keep in mind is that a Neptune year is 164.8 Earth years, which means that each season takes around 40 years to complete. This is just under double the amount of time that it takes Uranus to go through all of its seasons, which is 21 years. Neptune is lucky enough to have 14 moons that we're currently aware of, 5 of which were discovered by the Voyager science team. The largest moon was named after a water deity in Greek mythology called Triton. This moon was discovered by the same British astronomer that found 2 of the Uranian moons, Ariel and Umbriel. His name was William Lassell, and he grew up in the Manchester area making a living as a beer brewer before pursuing astronomy. Triton was the first Neptunian moon that was discovered, and there were only 17 days separating its discovery from Neptune itself. Triton has a retrograde orbit around its planet. This means that it orbits in the same direction that the planet rotates. This is a very rare occurrence, and it's the only large moon in our solar system that does this. The diameter of Neptune is 30,599 miles. This is almost 4 times the diameter of Earth. Although this is extraordinarily big, Neptune is still one of the smaller gas giants in our solar system. It occupies a spatial volume 58 times more than Earth does. Knowing this, it might be common to assume that Neptune is 58 times heavier than Earth, but this would be an incorrect assumption. It's not the case at all. Due to its composition of much less dense materials, you would only need 17 Earths to occupy the mass of Neptune. The surface gravity of Neptune has the second largest pull of all the planets in our solar system. That being said, it's only 14% stronger than what we experience here on Earth. The gravity experienced on Neptune is 11.15 meters per second per second. Meters per second is the measurement that we use to quantify acceleration. 11.15 meters per second, or meters per second squared of gravity means that if you drop an object on Neptune, each second after letting go it will be travelling towards the surface an extra 11.15 meters per second. So 1 second it will be travelling at 11.15 meters per second, at 2 seconds it will be travelling at 22.3 meters per second, and at 3 seconds it will be travelling at 33.45 meters per second, and so on. This assumes that there's no air resistance slowing the object down. You would eventually reach a point called terminal velocity, where there can be no more acceleration due to gravity and drag becoming equal. The gravity we experience here on Earth is 9.8 meters per second squared, meaning that if you were somehow able to stand on the mentally fabricated surface of Neptune, you would have a fairly difficult time noticing a change in gravity, as there is only a 14% difference. If we define the surface of Neptune as the point where the atmospheric pressure is equal to atmospheric pressure at sea level here on Earth, 14.7 psi, we could say that the average surface temperature is minus 201 degrees Celsius. This is incredibly cold in comparison to anything that we can experience here on Earth. As you descend deeper into Neptune's atmosphere, the temperature increases until you reach the core, where the temperatures can be as high as 7,000 degrees Celsius, comparable to the surface of the Sun. That's it for today's video. If there's anything that we can take from this, it's that Neptune isn't just a boring pale blue spot found in the telescopes of astronomers. It's a treasure trove of many different interesting things to learn. Don't forget to like, comment and subscribe if you enjoyed this. It motivates me to make more. I haven't uploaded a video in close to 2 years, and I think it'd be good to start making them again.